piecewise defined function versus step function. The step function is also known as Heaviside function. So we have the definition for the step function, which is coming from piecewise defined form. So the notation will be u t minus c, or you can just say uct, which is defined as a piecewise function. The first part will be 0 when t minus c less than 0, or you can say t less than c. And the other part will be always 1 when t minus c greater or equal to 0. Now we are having a piecewise defined function ft. It is 0 when t minus 2 less than 0, and it will be t squared minus 4t plus 10 when t minus 2 greater or equal to 0. So we will see the connection how to make a step function and go from piecewise defined function. So from one structure, we'll see it very easy. The structure is very simple. When you say t minus c less than 0, we can say t is less than c. So we put a c here. When t is less than c, the value is 0. And when t is greater than or equal to c, it is 1. So this c can be written as u t minus c as a step function. And we know that this piecewise defined function is now coming as u t minus c, and then first you write 1 minus the left side value 0. So that is exactly the definition you can see here, ut minus c. So that we get. So let us go to the next step for ft. So same way we produce the values here. So t is less than 2, so put a 2 here, and t greater or equal to 2. Then the right side, when t is greater or equal to 2, we have t squared minus 4t plus 10, and this side is have 0. So these two you can write as a step function u at t minus 2, and then we know the times the right side function or the value t squared minus 4t plus 10 minus 0. So you can just get this. So the ft, piecewise defined function, now converted to a piecewise defined function very easily. Now we have a step function here. We want to find its piecewise defined form. So first in the try, we write like this, that you have 3 and then you have 9. All right. And we will determine from the very basic definition. First, you can see u t minus 3 can be written as 0 when t is less than 3. We will just write less than 3. And it will be 1 when t is greater or equal to 3. And the other part, u t minus 9 will be written as 0 here when t is less than 9, and it will be 1 when t is greater or equal to 9 by definition. So now we plug the values here, like ft as a piecewise defined function. So first we are saying t is less than 3. When t is less than 3, so this 3t we can keep your 3t here. Now see the value of ut minus 3. So ut minus 3 when t is less than 3 is 0. And also t less than 9 for t minus 9, 0. Then the next part, t will be greater or equal to 3 less than 9. So what happens in this case, let me put 3t. Now we see t is greater than or equal to 3. This is 1 minus, when t is less than 9, then we see ut minus 9 is 0. And then next part is t is greater or equal to 9. When t is greater or equal to 9, we can see it is 1 here, and then we are going t greater or equal to 3, so that is 1 here, so 1 minus 1. So finally, you can see these values are coming as, so we have got our function ft equals 0 when t is less than 3. It is 3t when t is between 3 and 9, 3 inclusive, and it is 0 again when t is greater or equal to 9. So you can double check from this piecewise defined function. You can easily go to the step function or Heaviside function.